One of the great challenges of our lifetime is transitioning away from a fossil fuel-based energy system to one that is sustainable. Key to overcoming this challenge is to generate clean electricity and to electrify sectors that were previously dependent on fossil fuels. This comes with great challenges. Renewable energy sources like wind and solar are more volatile than conventional ones, and electrifying additional sectors, such as heating and transportation, will likely increase power demand significantly. To overcome these challenges, we need to adapt our energy infrastructure and develop instruments that will help us to operate this future system. At the NCCR Automation, leading researchers are working on these tasks.
In a system with increased levels of renewables generation, it will be more difficult to maintain the balance between generation and load. Storage, but also flexible load, such as shiftable demand and therefore boilers, heat pumps, electric vehicles, they can help to maintain that balance. But it is very important that the user doesn't incur any inconvenience. How can we achieve this? Well, we can use and process data from distributed generation, from the loads, from storage devices, and develop control strategies that allow for the coordination of these different devices. And for all of that, we do need automation. And that's why at the NCCR Automation, we want to establish the scientific basics and the methodologies that are necessary to fully automate the electric power system of the future, from the individual components to the system perspective.
But what do concrete solutions look like? At the ETH Zurich, Onion Stanoyev is working on instruments that enable a more automated energy system.
In my project, I aim to develop a software framework that would enable thousands of homes and businesses that own photovoltaic systems, electric vehicles, or batteries to act together and to virtually create a power plant. By means of automation, we can coordinate the different components within the households and make them not only produce energy, but also provide stability services to the power grid.
To have the greatest impact, the methods developed by researchers of the NCCR Automation have to be tested in the real world. Our scientists therefore work closely together with industry partners. For example, with EKZ, the operator of the distributional power grid that delivers electricity to households in the canton of Zurich. As such, they are well aware of the challenges that the energy transition brings and which tools they require to tackle.
We need more intelligence in our network. First, we need the better monitoring of our network. Since the whole system becomes more dynamic, we need to know closer to real time what's going on in our network. And as a second step, we need to also manage our network more dynamically with automation. We have very close cooperation with academia to make our network smarter. And in that sense, the work that NCCR Automation is doing is very relevant to us.
A key aspect of the future energy system is that different sectors, such as electricity, heating and buildings, will be more closely intertwined. At the EMPA facilities, researchers of the NCCR Automation not only develop theoretical methods related to these sectors, but can also test them in real-life settings.
Here at NEST, we have a great opportunity to work with different live building demonstrators with people living or working inside them. This gives us access to large amounts of data, and we can also control those buildings to test the algorithms that we created in simulation on a real case study.
Overall, the energy transition is a complex and difficult goal to achieve. With the NCCR, we want to contribute to enabling this energy transition with our research on dependable automation.